students. This is a mathematics grade 9 lesson. Have a nice time with me. So we'll try to discuss now geometry and measurements. Under this lesson, main contents are here. The main contents are congruency of figures, similarity of figures, and in detail we'll see theorems on similarity and congruency. So here, further on congruency, what's congruency? Two figures or two polygons are said to be congruent if they have the same shape and the same size, or if one is the exact copy of another. If one is exact copy of another. But here in detail we'll try to see how we can identify two triangles are congruent. Two triangles are congruent. But the above one is true for any polygon or for any figure. So two triangles are congruent. Let triangle ABC and triangle DEF are congruent. These two triangles are congruent if 6 parts of these two triangles are congruent, meaning 3 sides and 3 pair of angles. 3 pair of sides and 3 pair of angles must be congruent correspondingly. Let's see these triangles. Let we have triangle ABC is congruent to triangle DEF. So if they are congruent, meaning a 3 pair of sides and 3 pair of angles must be congruent correspondingly. Angle A must be correspondingly congruent with D. Angle B must be correspondingly congruent with D. And angle C must be congruent with angle F. And also corresponding sides with corresponding position. Side AB must be congruent with DE, and side BC must be congruent with EF, and side AC must be congruent to DF. Any two triangles are congruent if they satisfy these conditions. But always it's not necessary to show these all 6 parts. There are theorems which will simplify this procedure. So let's see that. Some ways to prove congruency of triangles. The following postulates or theorems are used to show whether a given pair of triangles are congruent or not. The first one is side-side congruency theorem. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the two triangles are congruent. If we take, for example, these figures, let we have triangle ABC is congruent with triangle DEF. They are congruent by side-side congruency theorem, meaning if 3 sides of one triangle are congruent with the other side. Here we can understand AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. So without showing the corresponding angles are congruent, simply using this theorem, we can say a triangle ABC is congruent with triangle DEF by side-side congruency theorem. Then the second theorem, angle-side-angle theorem. Here, angle-side-angle theorem says if two angles of one triangle are congruent to two angles of another triangle, and if the included angle of one triangle is congruent to the second triangle, then they are called congruent by angle-side-angle congruency theorem. Here we can explain using this figure. Here we have two angles. Angle A is congruent to angle D. They have the same sign, meaning they are congruent. Here we have the same sign. It implies they have the same measure. And angle C is congruent to angle E. So we have two congruent angles, and the included side, that's AC, is congruent to DE, Therefore, these two triangles are congruent by angle, side, angle congruency theorem. Angle, side, angle congruency theorem. ABC is congruent to DEF by angle, side, angle congruency theorem. Another one, side angle side. If two sides and the included angle of one triangle are congruent to two sides of another triangle and the included angle, then the two triangles are congruent by angle side angle congruency theorem. And we can also explain using this figure. Here angle B is congruent to angle D. Since they have the same sign, they are congruent. And AB is congruent to DF and BC is congruent to DE. So that these two pair of triangles have two corresponding sides which are congruent and the included angles are also congruent. So these two triangles are congruent. By side angle side congruency theorem. So these three theorems used to prove any two pair of triangles are congruent or not. And we'll have another like RHS theorem, which is used to prove two right angle triangles are congruent or not. This RHS is only used to prove for right angle triangles only. But the above works for all. This RHS meaning right angle triangle, the hypotenuse must be congruent and one of the sides must be congruent. Here even we can like prove or explain this using the figure. This is a right angle triangle, another right angle triangle, another right angle triangle. So if we need to prove this by RHS, the hypotenuse must be congruent and one of the sides, if this side is congruent to this one. This is A, B, C, D, E, F. So using this RHS, we can prove these two triangles are congruent. They have the same or a congruent hypotenuse and they are right angle and one of the other leg is congruent. So these two triangles are congruent. As I said before, this RHS is only used to prove for right angle triangles. But the above three theorems are for any pair of triangles, for any pair of triangles. It works for any pair of triangles. So let's see the next one, similarity. A figure that have the same shape but that may have different size are called similar. They must have necessarily the same shape. Any polygons may be similar if they have the same shape. At least they must have the same number of sides, but they may have a different size. In similar figure, one is the enlargement of the other. For example, we'll have this a very small triangle. Then if we enlarge this triangle by a scale, it may be like large one. They may be similar. One is the enlargement of the other. For example, the second one is the enlargement of the first. So that in similar figures, one is the enlargement of the others. And angles in corresponding position must be congruent. Angles in corresponding position must be congruent. We have these two pair of quadrilaterals. quadrilateral A, B, C, D, and let this vertex is denoted by these numbers. If quadrilateral ABCD is similar to quadrilateral 1, 2, 3, 4, angles in corresponding position must be congruent. Angle at A must be congruent angle at 1. Angle at B must be congruent at angle at 2. Similarly, angle at C must be congruent with angle at this 3, and this D must be congruent with 4. But they have a different shape, as we can see from this figure. And corresponding sides have the same ratio, or is proportional. Let's brief with using this triangle. Let triangle ABC is similar to this triangle. Triangle DEF. Triangle DEF. Triangle DEF. So let ABC is similar to. This symbol is to mean similar. Triangle DEF. What is to mean? The corresponding sides have the same ratio or proportional. That is, side AB is proportional to what? DE. DE. Let the ratio of this will be like K or any real number. Always this K is a number which is greater than 0. And similarly, BC is another side of this, the first triangle over. Then the corresponding side of the second triangle is EF. EF. So they must have the same ratio, meaning AB over DE equals to K. Similarly, the ratio of BC to EF must be equal to K. Equal to K. Not only for these two sides. Similarly, it's true for AC over EF must have the same ratio. That's what? K. They must have the same ratio, or they are called proportional. They are called proportional. So to show any two like figures are similar, one, angles in corresponding position must be congruent and the corresponding sides must have the same ratio, or they must be proportional. They must be proportional. So let's see how we can show like two triangles are similar or not. So we can use these theorems. Side angle, side similarity theorem. Side angle, side similarity theorem. So let's see what it means. If two sides of one triangle are proportional to another triangles and the included angles are congruent. Here look this one. Angle sides in corresponding position must be proportional. They must have the same ratio. They must have the same ratio. Let for example, this is like ABC, and another triangle, DEF. If they are similar by side angle, side similarity, meaning if angle A is congruent to angle D, because in similar figures, angles in corresponding positions must be congruent, And if AC over DF equals to, since the second figure is the enlargement of the first one, from AC and DF, from the figure, DF is the larger one. So its ratio is necessarily less than 1. So that let's say, let it will be 1 over 3. And similarly, to be they are similar, AB over, then the corresponding side in side AB is DE. DE must be equal to the same, that's 1 over 3. So here we can understand the two sides and the included angle. The two sides must have the same ratio. According to our example, it's 1 over 3. And angles in corresponding position, that's A, is congruent with D. So you can prove any two like triangles are similar by side angle similarity using this idea. Then the second one is angle-angle similarity. Angle-angle similarity. If two angles of one triangle are equal in measure to other angles of another triangle, or in terms of this we can use they must be congruent. If two angles of one triangle are congruent to two angles of the other triangle. Or even if two triangles are congruent, meaning all three angles are also congruent, but no need to show all three triangles. The last one, side-side similarity theorem. Side-side similarity theorem. If three sides of one triangle are proportional to three sides of another triangle, or if they have the same ratio, then they are similar. Here, let's see the statement. If three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. So let's explain like this similarity using example. Here we have two triangles which are similar. Find the lengths of DF and FE if triangle ABC is similar to triangle DEF. If they are similar, meaning the corresponding sides are proportional. Here, side AB is corresponding with DE. So AB over DE equals to, then BC is corresponding with EF and AC is corresponding with DF. So AB over DE equals to BC over EF, which equals to AC over DF. So let's substitute these values. Here, the distance from A to B is 4 centimeter, and DE is 10 centimeter as given, and BC is 7 centimeter. Then the corresponding side to this, which is EF, is Y, which equals to, that's AC 6 centimeter over X. So using this, the first two equations, 4 centimeter over 10 centimeter, which equals to 7 centimeter, then over Y. So we can evaluate here Y. So Y equals to 7 times 10, that's 70 centimeter square over 4 centimeter. That's Y equals to, you can find this one simply, it is 12.5 centimeter. 12.5 centimeter. And also to find X, this X, we can use this equation. That's 4 centimeter over 10 centimeter, which equals to 6 centimeter, then over X. Still, it is very simple to find the value of X. Very simple. That is X equals to 60 centimeter square, then over 4 centimeter. So we can find X equals to 15 centimeter. And even here, you can find what is a constant of proportionality, or the value of the ratio. Here, AB is corresponding with DE. DE, which equals to what's AB? That's 4 centimeter over 4 centimeter over. And what is DE? DE meaning that's 10 centimeter. 10 centimeter is equal to 2 over 5. This is called constant of proportionality. Constant of proportionality. Every corresponding sides will give this like ratio, which is 2 over 5. 2 over 5. So these are already the values that we have computed above. And the second example, find x, y, and m using the triangle below. Here DC is given, which is 9 centimeter. 9 centimeter. And EB, this is 3 centimeter. 3 centimeter. And AE is 5 centimeter. AE is 5 centimeter. Then find x, y, and m using the triangle. Here, to find these unknown values, use the idea of similarity. Use the idea of similarity. Here we have two triangles. Here we have two triangles. That is this very small triangle and the larger one. So first we have to show these triangles are similar. Angle A is common angle. Angle A is common angle. Is common for both triangles. Then another one, here angle at B here, and angle at C is right angle. That's angle ABE is congruent to angle ACD, which is equal to 90 degree. Which is equal to 90 degree. So we can use our theorem, the theorem. We have two congruent angles for these triangles, so that a triangle ABE is similar to triangle ACD. Triangle ACD. They are also similar by angle similarity theorem. If they are similar, meaning if they are similar, the corresponding sides are proportional or they have the same ratio. So to find the unknown value, let's use that idea. So that a triangle ABE is similar to triangle ACD. So that AB then over AB over AC, which equals to BE over CD, which equals to AE then over AD. So let's substitute the values. What the value of AB? The value of AB is x. That's x over what is AC? AC meaning the distance from A to C, that's x plus y. X plus y, which equals to what's BE? BE is already given there, which is 3 centimeter. 3 centimeter over what is CD? CD is also given, that is 9 centimeter, which equals to, and what is AE? It's also given 5 centimeter over, and the length of AD. The length of AD is, here it is 5, this one is M. So the length from A to D is the sum of this. That is M plus 5. So we can here write M plus 5. M plus 5. But here to find or to evaluate this like the values x, y, and m, we can apply another property here to find x. Here look this triangle. This triangle is right angle triangle. If it is right angle triangle, we can apply a Pythagoras theorem. Pythagoras theorem. A Pythagoras theorem meaning the square of the hypotenuse, that's 5 square, equals to the square of the sum of the other sides. That is x square, then plus the other side is BE, which is 3 centimeter. 3 centimeter the whole square. So if we evaluate this, x square equals to 25 centimeter square, then minus 9 centimeter square. Thus x square equals to 16 centimeter square. So x equals to 4 centimeter. 4 centimeter. So we have the value of x now. We have the value of x. So that to find the other values, so let's substitute 4 in place of x now. 4 over 4 plus y equals to 3 over 9, that is 1 over 3. 1 over 3. So if we make it this reciprocal, Theorem equals to 4 plus y, that's y equals to 8 centimeter. Y meaning the distance from B to C. But we are asked to find, even from like A to C, we can also find A to C is, this one is 4 centimeter, this one is 8 centimeter, so the distance of A from C is 12 centimeter. And also to find M here, 1 over 3 equals to 5 over m plus 5. So that's the same thing. Here, if you evaluate, m equals to 10 centimeter. Okay, then the competitions are like here. Already these are the values that we are computed above. So you can practice here. Angle A is common angle. Angle B is congruent to angle C, which are right angles, and therefore these two triangles are similar, not congruent, similar. They are similar by angle-angle similarity theorem. So if they are similar, the corresponding sides are proportional, or they have the same ratio. So that here AB is x, which is denoted in the above figure. Then over AC is x plus y, which is BC is given 3 over 9. And AE is, which is 5 over m plus 5. So that we can compute here from the above figure, triangle AB is right angle triangle, and we can find the value of x using Pythagoras theorem, and it's equal to 4. And if we substitute 4 in place of x, we'll have these values, 4 over x plus y, which is 3 over 9. So that y equals this. Simply the value of y will be 8, and if we solve here m will be equal to 10 centimeter. Ratio of perimeter and ratio of area of similar figures. Here we have a theorem. If ratio of the lengths of a corresponding side of two similar polygons is k, that is, if S1 over S2 equals to k, meaning if the ratio of the corresponding side is equal to k, then what will happen? The ratio of the perimeter and the area. It looks like this. The ratio of a perimeter of any polygon, any similar polygon, is also k. That's P1 over P2 equals to k, where P1 is the perimeter of the first polygon and P2 is the perimeter of the second polygon. And the ratio of their area is also equal to k square. Thus, A1 over A2 equals to k square. A1 over A2 equals to k square. So that, for example, if the ratio of S1 over S2 equals to 3, what will be the ratio of P1 to P2? Meaning the ratio of perimeter of the first one to the second, which is the same with the side, that is 3. And the ratio of A1 over A2 equals to k square, that is 3, the whole square, which will be equal to 9. So you can apply this theorem. to evaluate related problems. Here we have an example. The area of two similar triangles are 25 centimeter and 16 centimeter. Then, what is the ratio of their perimeter? Here, A1 over A2 equals to K squared, where K is the ratio of the corresponding sides. Here, 25 over 16 equals to K squared. So, if we evaluate here, K is 5 over 4. And the ratio of a perimeter is also equal to K. That's P1 over P2. P1 over P2. Similarly, you can evaluate this one. Two triangles are, if these two triangles are similar, the side of one is 2 centimeter long and the corresponding sides of the other is 6 centimeter long. What is the ratio of their perimeter and their area? We have here S1 and S2. S1 over S2 is here 1 over 3, which is K. And it is also equal to the ratio of a perimeter, and A1 over A2 is equal to K squared, and we have the value of K, which is 1 over 3. So 1 over 3 the whole square is equal to K squared. So the ratio of their area is 1 over 9. 1 over 9. So that here we can revise the main points here. We have seen what is congruent. Two figures are said to be congruent if they have exactly the same shape and the same size. And we have seen here theorems. Theorems how to prove any pair of triangles are congruent or not. Congruent or not. And another one on similarity. Similarity. Any two figures are similar if they have exactly the same shape, but they may have different size. And in similarity, one is the argument of the other, and angles in corresponding positions are congruent, and sides in corresponding position are proportional, or they have the same ratio. This is all about this lesson, and you can practice different examples on your textbook and different references. Thank you for the time.